So this video is all about solving the 10-2 problems, all about internal energy. In this problem here, we have a 3-gram copper penny drops a distance of 20 meters to the ground. If 75% of the initial potential energy goes into increasing the internal energy of the penny, determine the magnitude of that increase. So the first thing we're going to do, as always, we draw a picture. We have our penny and it's 20 meters from the ground. So we'll label that as well. We're given that the mass of the penny is 3 grams. We're going to have to change this to kilograms if we're going to solve for things in joules. There's 1,000 grams in a kilogram, so we divide by 1,000, and we get that the mass is 0.003 kilograms. We're also told that the height of the penny is 20 meters. The problem asks us to find the increase in the internal energy of the penny, which is delta U. But in order to do so, first we're going to have to find the initial potential energy of the penny. So we go back to our potential energy equation, and the potential energy equation says that we're going to multiply the mass, the gravitational field constant, G, and the height. So we'll solve for that first. We know that the mass we're going to use is the kilograms mass if we're going to get joules for energy. So we have 0.003. G is always the same number. It's always 9.81. And the height was 20. When we multiply those three things, we get 0.589. Being in energy, it's measured in joules. Now that is not our final answer though, because it asks for the increase in internal energy. So what do we do with this potential energy? It says 75% of that initial potential energy goes to increasing the internal energy. So we're going to have to take 75% of that initial potential energy. To do so, we're going to multiply by 0.75. When we multiply those, we get 0.441 for an answer. Being in energy, it's also measured in joules. So the main idea with these problems is it'll kind of tell you what to do in the problem itself. Here it said about the being 75% of the initial potential energy. If it said something about being a certain percentage of the kinetic energy, instead of using mgh, we would have used 1/2 mv squared. But we figure out which formula we need to use, either mgh or 1/2 mv squared. And then in this case, we had to take 75% of that to solve for the increase in internal energy.